And options for solutions. I'm Peter Schlosser. I'm the Deputy Director of the Earth Institute and the Chair of the local organizing committee of the Sea Level 2017 conference. Since Monday, more than 300 participants in the week-long international conference on sea level change exchange new information on changing sea levels, their impacts and possible solutions to the problems created by rising seas. The conference is organized by the World Climate Research Program and the Intergovernmental Oceanographic Commission of UNESCO. This open session tonight is focused on providing state-of-the-art knowledge on sea level change and its impact on society to a wide audience, and to address real-world issues experienced by those who have to make decisions on issues related to rising sea levels, including urban planning, management of infrastructure, or insurance of assets in regions at or close to the coast. I will now briefly place this event into the context of the Earth Institute's efforts in sustainable development to set the stage for the speakers and the panels that will follow. So if we are looking at the general context, we have to realize that the Earth system really is under stress. And if we are just taking a few examples, for example, during the past 3 centuries, the world population increased by a factor of about 10, energy use increased by a factor of about 16 in the 20th century, and that, of course, causes increases of greenhouse gases such as carbon dioxide, among other effects. The use of fossil fuels and agriculture led to these increases of CO2 and methane by about 40 and 100% respectively. So just based on these few examples, we can conclude the role of humans in the Earth system is by now so large that a new geological unit of time, the Anthropocene, has been proposed. Here we see how energy consumption, mainly by fossil fuels, has increased over time. And by now we are using roughly 18 terawatts, which is the equivalent to the energy production of about 15,000 nuclear power plants. That, of course, leads to the increase of greenhouse gases, mainly CO2, which is about 2/3 of the greenhouse gases, and that leads to the well-known global warming, which we actually see here as a time series, and in this graph you see how the world is warming as a whole, with some amplified warming in the high latitudes, specifically in the northern high latitudes. So by now we have increased global temperature by about close to 1 degree Celsius, and it has been concluded that it is virtually certain that globally the troposphere has warmed since the mid-century. So there's no doubt anymore that human impact has caused this warming. That, of course, leads us to the topic of the conference. If you are warming the planet, you are warming the ocean with it, and that in itself leads to the expansion of the volume and thereby sea level rise. And then, of course, you also have a second major contributor to sea level rise, which is the melting of the glacial ice that is sitting on land. And you might have heard or seen in the press that just between today or possibly 2 days ago, a big piece of one of the Antarctic ice sheets, the Larsen ice shelf, has detached and is now floating freely in the Southern Ocean. These combined effects, of course, do lead to a higher possibility of events such as the one that we saw during Superstorm Sandy, and it played out here in New York, among other places, and really forces us to act and act swiftly. To conclude this short introduction, I wanted to point out that in a very simple illustration, where the major issues are that we have to grapple with. Of course, the development and the population growth leads to the stress on the Earth system, as I pointed out, and we have to understand where this stress comes from. We have to look for solutions. We have to see if we can actually have if we have the economical means to implement them, if we have the institutional infrastructure to implement them. But if all that is doable, and that's actually a major task in itself, it does come down to whether or not societies are willing to change. And that is, of course, part of the dialogue that we have this evening. You know, where does all the information we get in these domains here translate into action, translate into change, and brings us into or along a trajectory that is more sustainable than the one that we are on right now, which definitely is not sustainable. So it is now my great pleasure and honor to introduce today's keynote speaker, the Honorable Scott Stringer. Mr. Stringer is a true New Yorker who was born and raised in Washington Heights. Over the past 25 years or so, he has left many marks on New York City's governance. He was, for example, elected to the New York State Assembly in 1992, where he represented Manhattan's West Side for 13 years. In 2006, he became Manhattan's borough president, and he was elected comptroller in 2013. He's intimately familiar with many of the aspects that face major cities such as New York, including environmental challenges, such as, for example, rising sea levels, because after all, we are sitting on an island, Manhattan Island, and sea level clearly is one of the major issues for complex settings of megacities such as New York. So please join me in welcoming Comptroller Scott Stringer to the podium.
Well, good evening, and I'm so honored that you would have me here tonight, and I want to start out by thanking Peter for that kind introduction and everyone here at the Earth Institute for hosting this impressive and critical conference. Now, I know many of you have traveled from around the world to be here, and I'm glad you did. And as city controller, I hope you spend as much money in this city. That's a plug, because we got to raise revenue. But the reason you're here is because now more than ever, we do need your energy, your research, and your urgency. You know, I still meet people every day who read articles on climate change, and they actually don't think it's going to matter in their lifetime. They think their neighborhood will never flood, the air will never be polluted. Those are problems for future generations, and by the time we have to confront this issue, we will have the technology and the wherewithal to make a difference. I used to think about that as a young person when you would read all the articles, but the reality is now clear. I know that as a father of a 4- and 5-year-old, 2 little boys, they're not my grandchildren, by the way, they're actually my children, and I worry about them, that they're going to have to confront an Earth unlike any other that they've ever seen in the world. The fact is, the rate of climate change is rapidly picking up speed. And I don't have to tell you, but according to NASA's Directorate of Space Studies, our planet is warming at a pace unprecedented in 1,000 years. So far this year, we've seen 9 extreme weather events, almost twice the normal rate. Since 2010, we've felt record warm weather 5 times more frequently than record cold weather in the United States. Just this morning, Larsen C, an iceberg the size of Delaware and weighing 1 trillion tons, broke off from the Antarctica. We are all in this room today because acting on climate change is not the right option, it's the only option. The urgency to act is upon us, and cities as big as New York have an important role to play. I know that, you know that. We need to move forward and act on that together. For us in government, that means planning ahead. It means arming ourselves with the tools and setting aside the funding we need to face the next climate-induced catastrophe. Because here in New York, we learned the hard way what happens when you don't have a plan. And I want to take you back to the night of October 29th, 2012, when Hurricane Sandy touched down. 10-foot waves pummeled our eastern shores. A 14-foot storm surge blew through lower Manhattan. 80-mile-per-hour winds ravaged Staten Island. We woke up in the morning to find 51 square miles of land, almost a full fifth of our city, submerged by severe flooding. An incredible $19 billion in damage. And worst of all, 44 of our neighbors, fellow New Yorkers, tragically were lost in that storm. Hurricane Sandy was the worst tragedy we faced since 9/11, because as a city, we were fundamentally unprepared. But not only were we not prepared for the storm, we were not even prepared for the aftermath. When I first became controller about 14 months later, we went out to areas impacted by Sandy to talk to residents about the recovery process. We heard heartbreaking stories of loved ones lost, homes ruined, and memories destroyed. But we also heard about a government response that was not fast enough or competent enough to support a devastated community. The city hired outside consultants to expedite the recovery instead of empowering our own Office of Emergency Management. So the city paid 2 independent contractors millions of dollars to clean up the mess, but when we did an audit of their work, we found that what they did was totally flawed. The work never happened at all. In its first year, the program Build It Back changed its policies and procedures over 100 times. The so-called recovery program was a case study in dysfunction. And to this day, Build It Back cannot seem to get the job done. 5 years and $2 billion later, thousands of families are still displaced from their homes and their communities. As I've said, we in New York City government learned the lesson the hard way. But in order to make sure we're ready the next time, we have to start investing in protections right now. As temperatures and sea levels continue to rise, so does our city's risk of severe flooding. Today, almost 85,000 city buildings, homes, schools, hospitals, and businesses now potentially sit within reach of floodwaters. That's more than $129 billion worth of property within FEMA's most recent flood plan map. But with climate deniers occupying the White House and the Capitol building, it's going to be up to local government to get this done. Attorney generals, treasurers, controllers have to move the dial, one city, one county, and one state at a time. Here's what we can do in New York. I believe we must launch a municipal green bond program, the largest in the nation, to give investors the chance to finance green projects to make our city more resilient. We've got to harden our sewage treatment plants, make sure that our solar power in our buildings have the proper installation. We've got to expand parkland and improve our mass transit system. Launching this program in New York would help develop the global green bond market and allow communities around the world to invest in our sustainable projects. Second, we have to leverage our financial assets to deepen our investments in a green future. I serve as the trustee and investment advisor to the 4th largest pension fund in America, the 14th largest in the world. And we have taken advantage of that position by investing a large portion of our $170 billion portfolio in green buildings, in solar companies, in windmills, in hydro projects, because we cannot continue to indefinitely invest in companies that prioritize short-term gains over long-term sustainability. We have to adjust now to a changing economy and a changing planet. We're also reducing our exposure to dirty and dying industries like coal. For the first time ever, the New York City Public Pension Fund have now divested from holdings from companies that produce thermal coal. And where we are still invested in oil and gas, we are working to change company behavior. We launched a national campaign with public pension funds from around the United States to make sure that we long-term share owners have the right to nominate and elect directors to corporate boards, so we can ensure boards are diverse and able to consider their company's impact on a warming planet. We've accomplished this in just 3 years. And third, we have to plan for a sustainable economic future. We're drafting the blueprint for how our pension fund can weather the impacts of climate-related risks for generations to come. We launched a carbon footprint analysis of our portfolio companies and hired experts to help us adapt our portfolios, preparing for risk and to take advantage of new investment strategies. The point is, as investors and as leaders, we can not only think about the next fiscal quarter, we need to think about the next quarter century. We need to accept, regardless of politics, that a sustainable economy is a resilient one that can bounce back from any storm, adjust to any change, and survive any obstacle. We have a long way to go to become the greenest, most sustainable city in the world, but I know we can get there because all of you have sounded the alarm and we are listening. We can and we will do more to cut our emissions and protect our people because our city and our safety is at stake. If we're united and not divided, if we put our heads together and maintain an open dialogue, we can get there. The events and the electoral events in the United States make this very challenging. I don't have to tell you what it means to have who we have in the White House and the climate deniers that now are so much part of our government. But I do fundamentally believe that cities around the world, smart cities around the world, can actually step up to the plate and transform the policies and the attitudes that we need to shake if we're going to make fundamental change. In the meantime, we have to have an inside-outside game. My role as a fiduciary of the pension fund is our ability to work with our other trustees, our union brothers and sisters who protect the retirement security of people of diverse backgrounds. We want to make sure their retirement is secure. But we also want to push the envelope. We also want to move the needle so that we can make sure that someday, perhaps in our lifetime, we can have a portfolio and an ability to create policy that will make New York City lead the nation in the kind of fundamental change that we need to protect our planet. For me, I got skin in the game like many of you. When I see my little children, I realize that the way to act and the urgent need is we have to act today, not for ourselves, but for them, for all the children we're never going to meet in countries and cities around the world. So I am so proud that you would give me an opportunity to speak with you today. The work you do is so critical. I really hope that you will appreciate that there is a role for government to play in this. I only wish sometimes we just played in a more productive way. Thank you for being here in New York and at Columbia. It really is an honor, and I wish you much success in the days ahead for your conference. Thank you very much, and thank you for giving me an opportunity. Thank you.
Thank you very much, Mr. Stringer, for these inspiring and actually optimistic remarks that gave us some insight in how cities can take actions and can develop long-term visions on issues related to climate change in general and sea level in particular. I would now like to introduce Dr. Gavin Schmidt, who will moderate two panels, one on the foundation of science, underlying sea level change, and the other on stakeholder needs. Gavin is director of NASA's Goddard Institute of Space Studies, known as GISS, just down the street here above Tom's Diner. And he is a climatologist, climate modeler, and importantly, he's the co-founder of the award-winning climate science blog, Real Climate. Gavin is actually trained as a mathematician at Oxford, and I think, if I'm not mistaken, at Jesus College. I have to check that with him. And then he moved on to the University College of London to get a PhD in applied mathematics. And he spent most of his career here at GISS in various roles as a scientist and then as a leader of the institution. Gavin's broad presence in the media and in communicating climate issues have been recognized by Earth-Sky, where he was the Science Communicator of the Year in 2011. Also in 2011, he received the American Geophysical Union's inaugural Climate Communication Prize. And in 2004, Gavin was named one of Scientific American's top 50 research leaders. So he's clearly a pro in communicating things, and he's, we could have thought of no one better to moderate these two panels. Before asking Gavin to take over here on the stage, I just want to welcome everybody who is following the webcast, and would like to make sure that you see that the Twitter feed is open, and it's hashtag #SeaLevel2017. So you can feed your questions into the proceedings here. Those of you who are in the audience, you should have little note cards where you can write your questions for the panelists, and just pass them to the end of the rows in which you are sitting, and people will go around and pick them up, and then they will be handed to Gavin, who will sort through them and will ask your question to the panel. So please join me in welcoming Gavin to the podium.
Thank you very much. So the very neat thing about moderating a panel is that I don't actually have to prepare anything, and I have very little to communicate to you. So all of that great introduction is kind of moot. But thank you anyway. That was very nice. Okay, what I'm going to do is I'm going to have the panelists come up. I'm going to introduce them. They're going to give their talks. I'm going to be very strict on the timing, because although you have great things to say, and I'm sure you could all fill up the entire time on your own, there's a lot of people here, and I think the key thing about communicating the science and the importance and the stakeholder visions that you have is that we need to be able to interact with the people who've come out this evening, thank you very much, and the people who are following us on the webcast. So I really want to maximize the amount of time that we have for questions and for interactions. And so if I seem a teensy bit kind of with your presentations, please forgive me in advance. Peter mentioned the hashtag. Let me just repeat it for you. Hashtag SeaLevel2017. It is being monitored, and so questions that come through that portal will be brought up to the front, and hopefully we'll be able to get to a lot of them, as well as your questions here. There's some tables at the back with interesting swag and games. There's the Polar project over there. You've got games on Arctic ecosystems. You've got the NASA table at the back with some great stickers and holographic things to put on your wall. And there's some literature around on sea level and the programs that both Columbia and some of the other institutions are putting forward. There's some good stuff there. So hopefully you can get some time to go and say hello to them. So, with no further ado, do we want to bring up the whole panel? Just one person at a time, right? One at a time. Yes. Okay, so one at a time. So our first panelist is Robin Bell, who's a research professor at Lamont-Doherty, just across the river in Palisades, and has been a stalwart member of the faculty here, working on Antarctic issues. Come on up. I haven't got an introduction, so just keep going, keep going. And so I'm going to turn it over to you, and if I need to, I'll give you a little timer with a minute to go.
Okay, good. Alrighty. Thank you very much, Gavin, and we'll see, I'll see how long I can go just to see how I can irritate you. Well, thank you very much for coming. My goal today is to, I'm on the causes side, so we're going to hear more about the impacts and the solutions from Jim and George, but I always like people to think about what a beautiful place our planet is, in particular, what a beautiful place Antarctica is, because often we end up with this sense that it's very scary. It's not really scary, it's beautiful. So, first off, our planet has two ice sheets currently, one in the north and one in the south. The one in Antarctica is much bigger, and it matters the most for us here in New York, if we're going to be very self-centered, because of the way, actually, the ice sheets pull the oceans towards them. So Antarctica matters. So even though it seems really esoteric to be sitting here in New York and talking about Antarctica, it matters the most for us. The really important thing I want you to walk away with is what's the evidence? How do we know the ice sheets are changing? There's 3 independent measurements, and we're just going to look at one place in Antarctica. And what we really know is that over the last decade, we've seen the ice sheet move from about a mile or 2 kilometers a year to, in that same place, we now see it moving 2 miles a year or about 4 kilometers a year. So we've seen the speed double. And at that same time, because ice is like silly putty, when it goes faster, you stretch it, the elevation drops. So you can see the big yellow blob showing up. That's the same place that we saw the ice speeding up. So 2 independent measurements. The ice is speeding up, the ice is dropping. We have a third measurement from the same place that shows us that the ice is losing mass. So what this is a pair of satellites that measure the mass of the ice sheet from space. And what you can see in that same place we were looking at before, a place called Pine Island Bay, no pine trees there, but that's what it's called, that we're actually losing mass. So when people ask me, do I believe the ice sheets are changing? It's like, it's not really a belief. Let me show you the 3 lines of evidence, 3 independent measurements. This is what it is. I could show you the same thing in Greenland, but since Gavin's going to yell at me, you're going to have to take my word for it. Or go look for it yourself, or back at the NASA booth. They can show you the cool images. You can get a postcard like this back there. So Antarctic speeding up, dropping, and losing mass. The models suggest this change in the future could be fast. This is one by DeConto and Pollard, 2 friends of mine, who have worked to show that given some of the aggressive warming we could see on our planet, we could see this ice sheet in this half of Antarctica go in the next 500 years. We could see a meter of sea level, basically up to my waist, by 2100. So this is important. This matters for us. What are we doing? We're trying to push the edges of science, and that's a lot of what's happening today, is trying to understand, is this projection right? This is what a lot of the cities, we heard San Francisco and New York talking today about how they're using the numbers out of this model, but there are things we still don't understand. Remember that evidence I showed you? That was all from space. We still have to get up close and personal to understand, because those models are only as good as our input on what the planet looks like and our input on what the physics are behind how the ice flows, deforms, and changes. But there really is a moral and social imperative to explore and understand how our planet works. So that's what my job is to try and figure out how the plumbing and the ice on our planet works. Because there's some things that we need to improve in our models. If we can tell people in San Francisco and New York what's the best number to use to plan. We need to know what's going on underneath the ice, because it really matters. This is a picture of what happens if you pull up the ice sheet. Oops, sorry, I moved it forward. You can see it doesn't. You might just think it's a flat, boring place. I used to think it was flat and boring. It's not. It's a really rich environment. There are mountains, there are lakes, there are places it slides fast, and there are places that can funnel in warm water. So we need to know what it looks like underneath. There are places, if we had Manhattan underneath the ice sheet, we'd have one measurement on what the elevation was. That's one of the problems with the projections we have right now. So we don't know what's going on underneath the ice sheet. We also don't quite know what's going to happen when the air warms. We certainly know there's going to be meltwater on top of the ice sheet, because we see that in Greenland. But we don't know whether that water is going to fall in great big ponds, which are kind of dangerous for ice sheets, or if we're going to get giant rivers and waterfalls that would remove that damaging water. So those are just, we don't know what's underneath the ice sheet. We don't really know what's going to happen when the air warms. And then the third thing that we're really trying to push the borders of is understanding what the temperature of the ocean is, because that's the other way you can make an ice sheet go away, is by putting warm ocean water up. This is an experiment we did last year where we took that instrument and threw it out the back of the airplane, and it went in the ocean, and the marvelous thing was it phoned home a temperature profile of the ocean before the plane landed, and was phoning home until it got covered with sea ice. So these are the kind of things we're doing. We're still trying to push to understand what's underneath the ice sheets, what happens when the air warms to that surface meltwater, and what's going to happen when warm water gets close to the ice sheet, and is there warm water getting close to the ice sheet? So, where are we looking in the future? So the real science is that we need to understand better how the ice sheets work, because it's a challenge to the coastlines, and this is going to help us tell the modelers how to improve their projections of future sea level. And it's really going to take getting up close and personal with an ice sheet. It's not something we can do from a satellite. You can't see underneath an ice sheet. You can't understand how it works. So, there is an entire generations of work to do, in my mind. Understanding ice sheets are kind of where understanding the oceans were about 50 years ago. We have a lot of basic measurements, but we're still trying to understand the processes and some of the key topography even. So thank you very much for coming, and now we're going to turn it over to Jim, who's going to talk about what's happening to all those ice cubes that we're busily throwing in the ocean. I'll sit down and watch it.
So what I'm going to talk about is some science regarding how you actually predict sea level, current sea level change at specific locations on the Earth. One of the things you have to internalize is that sea level change is different in different parts of the ocean. That may seem a little counterintuitive. When we draw a bath, the level of our bath water is very even. But over the globe, a number of different physical processes, and I'll discuss a few of them today, cause sea level to change at different places at different times. That's an image from a satellite radar that measures the surface of the ocean. And here I have some actual sea level plots from two different places on the east coast of North America. The top one is from St. Petersburg, Florida, and the bottom one is from the Battery. You can just take the one line south and see this white, ugly box sticking out into the water, the very tip of New York. And this shows sea level as a function of time for about the last 60 years. And one thing that you can see is that is this the laser pointer? Yeah. Is that there's been an acceleration in sea level in, say, the last 25 years. And that's been well documented. But one thing that you can see here is it's quite different for Florida than it is for up here in New York. And that's part of this whole process of the sea level being different in different places. And I'll discuss that. One of the most important processes that's been going on, certainly before the industrial period, sea level's been changing. It's been changing really not in response to the current climate, but in response to the climate change 15, 20,000 years ago that actually changed the shape of the Earth and its gravity, and that's post-glacial rebound. And even without any present-day climate change, places like the east coast of North America have about 1 millimeter per year of sea level rise. That's a little head start, I guess, that we got on sea level change due to present-day climate. Another contribution to sea level change is the actual density of the ocean and circulation of the ocean. And here, you don't have to worry about the exact numbers so much, but just to see this pattern and shows the variability of, in this case, sea level acceleration along the east coast of North America. You can see there are places where it's negative and places where it's positive. This is from a model that oceanographers run to study the ocean circulation. And you can see some of the shortcomings that we are currently dealing with, even in the resolution of the model. The model doesn't necessarily come to the coast where we're most interested in sea level rise. The thing that we most associate with sea level rise, the melting of glaciers, also causes variable sea level change. And this shows the sea level change in the same region, the acceleration due to accelerated glacier melt that's been observed by satellites that measure the gravity over Greenland and other places. And you can see close to Greenland, you actually get a bit of a sea level fall, and then you get this change in sea level change. So the fact that the sea level acceleration that we see is different in New York City than in Florida is explained basically by the processes that go into it. Of course, we also have to remember that the way we experience sea level is not either just sea level rate or even sea level acceleration. It's not, this slow thing. Yes, it will be up to your waist, but that's not how we experience it, right? And we experience it often with these catastrophic events that take the water that has been slowly piling up and then dump it on you and remind you that it's there. This is Sandy. This is a catastrophic event, but it now is starting to happen even at high tides in some places. The sea level has risen enough so that every high tide or frequently at high tides you get flooding. This is a non-climate related process per se. This is New Orleans, and New Orleans is sinking. And other processes, some usually man-made, it's sinking because of, I forget why, actually groundwater and maybe petroleum extraction caused the land to subside. We saw some work today on China and coastal Asia. And what that means is that other processes that we had to deal with now are just much worse and make the already difficult changes to deal with catastrophic. So the important thing, the thing that I think like you to go away with, is that, first of all, local sea level is the important concept for stakeholders. If you're interested in what to do in your city, in your locality, you want to know what sea level is right here. You don't care what the global mean is per se. And so local sea level is what you need to do. And that means trying to understand the individual sources of the sea level change in detail. That means not just saying vaguely, oh yeah, there's melting going on in Antarctica and in Greenland, but saying, okay, how much melting is going on in Antarctica? How much is going on in Greenland? Where are we with respect to that? How much are the ocean currents changing? And putting everything together to try to understand exactly what's going on at your location. The theory behind this is well established. What we're really lacking now, not completely, but fairly well established, what we're really lacking are observations, continuous observations, spatially more broad observations, as well as improved modeling. These are, I would say, sort of barely adequate to explain what we've seen in the last few decades. And that sort of scale, then, I would call them inadequate for the kind of accurate prediction that we'd like to make into the future. The other thing I'd like to comment on is how, the pipeline, by the way, this is what's known as the Greenland fingerprint. So if ice from Greenland melts, this is the pattern of sea level change that you get. And because of the kind of swirl pattern, it's called a fingerprint. This kind of, the science, the pipeline from the science, from the research, to the stakeholders and the general public is not very well established. It's well established, say, for weather forecasting. If someone says, it's going to snow next week, well, maybe not in July, but if someone says it's going to snow next week, maybe a 30% probability. We've all internalized that. We know what to do. Cities have plans. Everything is undertaken. It's still rough sometimes. But for climate change and sea level, really, we haven't begun to develop that kind of strong pipeline. Thank you. Everyone's going to be looking.
Next up, George Deodatis, who's going to talk about the engineering challenges involved in dealing with this.
Good evening, ladies and gentlemen. My colleagues talked about the science behind sea level rise. I'm an engineer. I'm a civil engineer. So I'm going to talk about what can we do as a society to protect primarily coastal communities from the combined effect of coastal storms, hurricanes, and sea level rise. And these two have to be always considered together. I would like to acknowledge my colleague, Kyle Mandley, from the School of Engineering here at Columbia University. We are working together on this project. Oops. This is an old version of my presentation. There are no photographs. That's OK. I had 2 photographs at the bottom from Hurricane Sandy. And a very important point is that as we are preparing for the next major storm that will hit our area, we have to keep in mind it's not going to be the same as Hurricane Sandy. It's going to be quite different. For example, during Hurricane Sandy, lower Manhattan was in high tides. Future hurricane might find lower Manhattan in low tide, and other areas that were in low tide now can be in high tide. And the damage distribution can be quite different. Also, a future hurricane can come from a different direction with different speeds. It can hit a little bit to the east in Long Island. There are a lot of different possibilities. So we have to consider that future events will have a lot of uncertainty involved. Plus, we have to consider together the expected sea level rise. Because keep in mind, if Hurricane Sandy repeats itself, let's say 100 years from now, and we have a 4 or 5 feet sea level rise, the effects are going to be much, much more catastrophic. Or a smaller storm with a 4 or 5 feet sea level rise will be much, much more catastrophic. What can we do? There are a lot of different protective measures that can be implemented. I have listed here a few. Barrier island preservation, you see, beach restorations, building breakwaters, living shorelines, shoreline stabilization. These protective measures will break down the impact of an incoming storm surge from a hurricane or a storm. You can build flood walls, sea walls, levees. If you don't like having walls, they look quite artificial. Sometimes they block the view in a nasty way. We can consider sand dunes. Or we can consider deployable flood walls that down most of the time they go up just before a storm arrives. We can go to larger measures like storm surge barriers. Storm surge barriers are large structures. A classical example is the one built to protect London. It has worked very, very successfully over the years. There are proposals to build storm barriers close to the Verrazano Narrows Bridge in the New York City area and in a few other areas. So this is a much larger scale type of protective measure. We can protect individual structures by sealing them, retrofitting them, or raising the infrastructure. You must have seen photographs of houses on stilts become much higher, and they're not affected from flooding. However, it is extremely important to start considering some more drastic measures that are quite sensitive and delicate. For example, if you have communities that have repeatedly been damaged, devastated from storms, at some point we have to start thinking about relocating the entire community to higher grounds. You realize people have lived there for generations. It's not an easy topic to talk about, but since this is not something that we'll try to implement next year or 5 years from now, this might be a solution that might have to be implemented 50 years from now. It's important to start talking as soon as possible. Of course, other types of solutions, changing land use and zoning laws, and of course, through insurance and reinsurance. I have also here catastrophe bonds. It's a financial instrument that can help us along these lines. Now, what we are working on is to establish a general methodology to determine the optimum protection strategy for a general geographic area over a prescribed period of time. Critical parts will be to consider the combined effect of sea level rise and storms. Just considering the effect of storms, it's a huge mistake, because you don't want to spend huge amounts of money just taking care of the next storm without keeping in mind that sometime in the future you have to add 1, 2, 3, 4, 5, and even more feet of sea level rise. Now, an important part of this methodology is that budgets are not unlimited. We have to consider a constraint of the overall amount of money involved. Keep in mind, if you give limitless amount of funds to civil engineers, they will build everything up and they will protect everything. But this is a fallacy. There is not unlimited amount of money. We have seen this very, very well. Now, the optimum strategy is definitely not going to be just one protective measure from the list that I just showed you. It's going to be a combination of a lot of different protective measures implemented at different locations in a larger geographical area, considering, let's say, New Jersey, New York, including Long Island, and at different times. It doesn't mean that everything should be implemented within the next year. No. Different measures at different locations and at different time instance. Of course, the basis is a benefit-cost analysis approach. However, stakeholder feedback and social acceptability are absolutely critical. You might have the best plan in the world. If it's not accepted by society, it's completely useless. Detrimental side effects should be considered, because keep in mind, you never want to implement a preventive measure in a specific community that will have detrimental effects to neighboring communities. So once such a strategy is established, we should be able to have the best use of available funding to provide the optimum level of protection in large periods of time, let's say 5, 10, 20, 100 years, 200 years, and so on. Thank you very much.
Okay, that was very well done. Well, good timing, people. So we have the science, right, of why the ice is changing. We have what's happening locally, which is important. Though you did mention trying to improve the pipelines. I'm thinking that was what's causing the problem in the first place. So perhaps not. Oh God, come on.
I got it. I got your joke.
Right, that was a joke. I'm trying to be, trying to communicate. Never mind. Moving on. It's going to be one of those nights, right? Okay. So we've already got some questions from Twitter, and you'll be surprised to know that none of them are offensive. They're actually quite sensible. So we'll just start off with that. And remember, if you have questions in the audience, there are people who are going to be collecting the cards at the ends of the rows. So please pass your questions to the ends of the row. And we have 15 to 20 minutes here. So hopefully we'll get through a lot of the questions that you have. So here's really one for Robin. Does it matter where the ice recedes in Antarctica for a question such as the sea level rise along the east coast? Does it matter that it's the Pine Island Glacier or West Antarctica or Thwaites, or does that matter in the far field?
So the way the fingerprint, which is what Jim talked about, is I kind of think of like it's a halo around the ice sheet, and it matters whether or not you're in that halo or that shadow. So once you're outside of the shadow, it doesn't matter. So really, any change in Antarctica, we're going to see it here in Manhattan.
So what goes on in Antarctica does not stay in Antarctica?
No, what goes on in Antarctica does not stay in Antarctica.
Do you want to add anything, Jim?
No, just, I guess yes. But, the flip side of that is counterintuitively, if you do live near, say, Greenland, and there's a massive ice loss, your sea level actually goes down because your land is rising. So a place like Reykjavik, it matters not when, but the difference between Greenland and Antarctica is huge.
Okay. Next question from @Energis, and this is perhaps for George. Talking about the infrastructure that's currently at risk. How many nuclear power plants, chemical plants, refineries are within, a meter of sea level right now? I mean, what are we talking about in terms of the infrastructure that could be lost or needs protecting?
The study that we are conducting was considering New York City, the 5 boroughs. We don't have any nuclear plants within the 5 boroughs of Manhattan. However, there are a lot of other critical facilities within New York City. So we have to be very, very careful to protect other critical facilities, for example, hospitals, police stations, schools, power plants. And I believe that those of you from New York City remember last time the major disaster of having to evacuate the NYU hospital during Hurricane Sandy, emergency rooms, people in intensive care. So these are very, very important critical facilities that will have to be protected better. And there are currently plans, from what I know, for better protection of these facilities, including the subway system. The MTA has invested a very large amount of money to seal individual stations, ventilation shafts, and so on. But as far as nuclear power plants, again, we don't have any within New York City. We have Indian Point a little bit to the north. I have the feeling that there is no direct threat from sea level rise and hurricanes to Indian Point.
Okay. This is another one, I think, for Jim and Robin. Does the freshening of the ocean by the dumping of ice from Antarctica and Greenland and glaciers as well, does that affect ocean currents, biota, stratification? Are there going to be other effects from the freshening that we're seeing?
Well, if we're going to use, day after tomorrow as the basis, you don't think so?
I don't think
You don't
we
think
should
so?
use that.
Okay, no, I'm not supposed to talk about that?
No, we're not. See,
Oh.
that film was great because it's the only Hollywood movie that's ever starred a climatologist. And so,
Right.
like, all the climatologists are going, yeah, and then they watch the movie and they're going, oh.
Right, and all the glaciologists died in a mall in New Jersey, right? That was really bad. Anyway, so back to the freshening.
Yes.
Right, the freshening, which was the issue there, but there has been the hypothesis that it will impact circulation. In Antarctica, we actually see that some of those freshwater pulses actually cause tremendous algal blooms. It seems like one of the interesting discoveries that have been made recently, that there is a link between all the fresh water coming out from the Antarctic ice sheet, and which is similar to fluxes, say, of the Amazon, can support big algal blooms and tremendous water that's almost green in parts of Antarctica that are changing. So this is one of these feedbacks. We don't actually know what it is yet. We know that there could be an impact from changing the salinity of the water on what sort of ecosystem thrives there. But it's certainly one of these things we're just discovering what will happen. And we don't expect to see any result like after the day after tomorrow.
Okay.
There's also a density change with the salinity that does impact the sea level.
Right. Okay, so you mentioned that one of the things that's going on is that there's isostatic rebound. So when you lose the ice in Greenland, then the land lifts up. But someone else says, well, is there anything else going on? And I think there is.
Oh, anything else going? Well, I mean, that's sort of my view, my simplified view of the process. The process that's causing that's actually quite complicated, right? Because we always say melting, but there's a lot which does happen, but the ice is dynamic, as Robin showed, and some of the ice is actually moving into the ocean quicker. So how that mass loss occurs is a very complex process, and especially for prediction, we'll need a much better understanding of that.
So one of the things that we've been hearing about in the conference was this concept of self-gravitation. So the fact that the water is attracted to the ice there because of gravity, right? The masses attract each other, and when the mass is gone, then there's less gravity on the sheet, and then that actually allows the water to go down. So part of the diminution of sea level is not, it is because gravity has changed.
Right, that's true. It's a smaller part, but yeah, there's
it's kind of neat, though.
Well, one of the
that's clever, right?
One of the cool things that I thought we learned at this conference was that they can actually measure how the parts of Antarctica that I showed are changing, where you can actually see the ice speeding up and dropping. But they've actually gone out and put GPS, fancier GPS than the ones on our iPhones, but they can still phone home. But they've let them sit there, and they actually can see the Earth bouncing up 3.5 centimeters a year. I mean, to me, that's just mind-boggling that you can measure the response of the solid Earth to the changing ice.
Okay, so moving on from cool science to, oh my gosh, are we at an irreversible point at this time? I mean, like, what of the things that are going on right now are going to continue regardless of our choices, and what do we still have the ability to affect? Anybody?
You've talked to me about
George?
this, so you have an answer for that.
Okay, the sense of irreversibility is that the parts of the ice that are changing are sort of, if this part's the ice sheet and this is the ground underneath, the ground is tipping backwards, and so there's sort of the front of the ice gets steeper and steeper, and it runs faster. And that's the instability in the ice sheet. But the models say it might. Some models say we've moved past a tipping point, but that's where we really wonder how good the models are. That's where it might actually matter that the Earth is bouncing back up, because if the Earth is bouncing back up, it could change the slope and introduce new roughness. So I think I don't feel like we're past a tipping point yet, that we're still, the simple models say we could be, but there's a lot of other input into how the planet's responding to change.
Okay.
But the other thing is, even if we stop warming, we're still at the current temperature, which will cause continued ice mass loss,
Right.
correct?
Right.
Right. So Steve,
The critical question, of course, is irreversibility for what? Because we have to consider keeping, let's say, sea level rise below 5 feet by the end of the century. We always have to define what is the definition of irreversibility, because sea level rise will keep evolving between now and the end of the century. The question is at what rate?
right. Okay, that's clear. Very specific question. Can we predict the sea level rise for New York City depending on our choices? I mean, can we say 1 feet if we keep to the Paris Agreement targets? Or can we say 3 feet if we continue on business as usual? Do we have that kind of specificity?
I think we know that if we don't, I think we know that if we go to an RCP 8.5, that we are going to see more sea level rise here. I think that's pretty clear. I don't think, I don't think we can put our finger on whether it's going to be 6 feet in 2100 or 5 feet, but we certainly know that not keeping to the Paris agreements will warm the polar regions more. Remembering the polar regions warm faster than New York does, so we're going to see that polar amplification. We're already seeing the polar amplification. So there will be more the more we don't comply.
Okay, so here's a bunch of questions that I'm going to ask all at once, and they're really related to the engineering aspects. So what happens when you build a flood wall to the adjacent areas? So if we build a barrier across the Verrazano, what does that do to Coney Island? What about rezoning issues that don't include sea level rise as part of their mandate? How is flood insurance in New York City working? Does it work? Is it sensibly done? Any of those? Anybody?
Let me try to answer one at a time. The issue of the barriers at the Verrazano Narrows Bridge. This is a controversial issue. There is a group of engineers who strongly support this solution, and indeed, it's going to provide some protection, almost complete protection to communities behind the barriers. However, we have to keep in mind that the cost of this project is going to be huge, in the billions of dollars, and it's not going to be 1 or 2 billions. It's going to be, in my opinion, more than 10 billions. And the problem is that although the communities behind this barrier are going to be well protected, the majority of communities that have been devastated, for example, during Hurricane Sandy, will not be protected. The Rockaways are outside the area protected by the barriers, Staten Island, Long Island, New Jersey. So as I mentioned, some general methodology has to be developed to determine, does it make sense to build these barriers, or does it make more sense to use, let's say $20 billion is the cost of this storm surge barrier. Is it better to use the $20 billion in a series of different protective measures? I don't have the answer because the methodology is not still there, but my gut feeling is that it's not a good solution. First of all, just one barrier is not going to be enough. You have to build 2 or 3 more between Staten Island and New Jersey, in Long Island Sound. Everything has to be considered because such a huge investment is going to be considered. Now, as far as flood insurance is concerned, flood insurance in the past had very significant benefits, of course, but also it had some detrimental effects because people living very close to the coast, these people had their houses destroyed, and then flood insurance paid, and they had the houses repaired. Somehow, having this sense of insurance is going to cover me prevents people from making a decision, look, at some point, it might make more sense for me to move to higher grounds. So this is a controversial issue. Overall, you have to keep in mind insurance is very, very important. I mean, a lot of people have saved their houses, their belongings from having flood insurance. However, we have to keep in mind that flood insurance should not be taken as a guarantee that I can stay in this area forever. This is a very, very important part that has to start being discussed immediately. Some communities eventually will have to move to higher ground. There is no other way out. I don't remember now the middle question.
But that's okay. Okay, so a slight change of tack. Are we communicating this well? Right? So yesterday there was a big article in the New Yorker. No, in New York magazine, not the New Yorker. They might have done a better job with the fact-checking. But that has caused both a lot of people to be very concerned, a lot of people reading about it for the first time, and then a little bit of a backlash from scientists who feel that it was, to quote somebody, a little too doomist. So what do we think about that? Do we think that that's a good strategy for getting people interested and animated on the topic, or do we think that that is going to be perhaps self-defeating?
I call it the, we're going to drown you, or well, most people when they hear what they do, they think I'm going to drown them. And I think I guess what you do, Gavin, you're going to roast them. So it's, we as scientists are either going to drown you or cook you. And I'm not sure that's a very good...
I'd like to mention I'm a vegetarian.
Well, you can feed it to somebody else. Anyway, I worry that that is a very doom message, and we're turning people off without giving them any sense of hope. That we as a species are really lucky that we're the first species that's been able to see the planet as a whole. And yes, bacteria have impacted the planet before, but they didn't have satellites and computer models to understand what they were doing. So in some sense, we're really lucky in that we as a species can see our planet as a whole. And the question is how we move from the fact that we think we've gotten ourselves into, we're changing it faster than it's comfortable. How do we convey that there actually is hope? And so that we don't end up getting, because I think people turn off when we tell vegetarians we're going to roast them or drown them.
There's always room for improvement, but I'm a little worried that up till now, the main stories in the media have been focused on sort of the catastrophic, and even I haven't read stories yet about Antarctica today, but I wouldn't be surprised if it was presented without enough context to really understand whether it was anything besides, oh, we're gonna drown you. Right? What does that mean in terms of first of all, instantaneous sea level rise? Does that mean the sea level is just going to rise? And we know not, right? Of course, but not everyone will be able to infer that from the information. But even once we say, okay, it's not, it's an ice cube floating in the. So is this expected? Is it sort of surprise to us? Is it, the quotes are all, oh gosh, it's happening, and so I think overall these kinds of stories could be done better with more context, and maybe that's us to provide it in some way.
George?
There are so many different stories in the press and in media that some of them are treating the problem from a very rational point of view. Others probably provide a very, very dark version of the future. Overall, it's difficult to tell what is the most effective. And the general population, unfortunately, when they read these very, very dark predictions about the future, they automatically compare it with what is going on right now in our lives. And of course, sea level rise automatically is not affecting us this year or the next year. So we have to be very, very careful how these are portrayed in articles for the general population, and always emphasize that the effect is going to be felt in the future. In the future, when you will have the 3 or 4 feet of sea level rise, a medium-sized hurricane is going to feel like Hurricane Sandy because you will have to add the sea level rise, but not right now. It's not going to happen next year.
I'm going to disagree with you. It's happening right now. You go to Miami, sea level rise is happening right now. You go to Newport News, sea level rise is happening now. You go to small islands in Indonesia. We saw this afternoon small islands that are totally flooded for more than half the year. Those are places where sea level rise is a very, very real concern. This is not just something for the future.
It is, and it is for island nations that you mentioned, but I'm talking about, let's say, New York City. Right. Unfortunately, memory of the general population is not very, very long. There was the effect, of course, of Hurricane Sandy. It lasted 1, 2, 3, 4 years. If a similar event is not going to happen in the next 5 years, it's not going to be having the effect that it had in the beginning.
In an event like this, 10 years ago, we could have all pretended that New York was, in fact, the center of the universe and nothing outside of here mattered. But unfortunately, now we're being webcast to the rest of the world. So we no longer have that luxury. We actually have to pretend that the rest of the world also matters. Yes, tricky. Okay, one last question, and then we're going to go on to the next panel. What coastline would you miss most in 100 years' time? Very quick. George.
I would say that there are some countries, for example, like Bangladesh, that is very low-lying. And the rise of the sea in this country will have a really devastating effect. And it is a country that doesn't have the resources, let's say, of the United States to take measures. So I have the feeling that Bangladesh might have some very, very serious problems that it will have to resolve, and the population is very, very large in that.
Jim.
There are so many areas that are really threatened, and many are populated, but I lived in New England a long time, and I'm worried about Cape Cod.
Well, I was going to say Cape Cod, but because I can't, since you did.
You can.
Okay,
you can go with Cape Cod.
I think the beautiful sand beaches of New England. I think those are things that, are they were little scum left over from the last glaciers, and they're going to be the first ones to feel the impact of the change in the South.
So I'll allow myself to answer this one as well. I like Miami. I'm going to miss Miami. And Louisiana. Louisiana is interesting.
Yeah.
That's going to be a shame. Okay, so thank you very much for your answers and your presentations. Please give them a round of applause. Thank you very much to all the questions that came up. I didn't get round to kind of all of them, but I've kept a couple for the next round as well. And thank you very much for the people on Twitter who also sent in some questions that we did get to. So now it's time for the stakeholder panel. And again, we have a short period where we're going to have their presentations, and then we'll have hopefully another 15 to 20 minutes conversation after that with your questions. So if you have questions that are particularly tied to these kind of stakeholder issues, be writing them down and be tweeting them to us at #SeaLevel2017. So our first person for the stakeholder panel is Jainey Bavishi, who's the director of the Office of Recovery and Resiliency of the Office of the Mayor in New York City. So welcome.
Well, thanks so much to the organizers for organizing this really important conversation between scientists and practitioners and policymakers. And I'm honored to be part of this all-woman panel that is focused on solutions. Hurricane Sandy was a pivotal moment in the city's climate action agenda, and I won't go into the impacts since Comptroller Stringer already stated them, but I do want to mention that the impacts of Sandy were often exacerbated by challenges that neighborhoods across the city face on a day-to-day basis, whether it's inadequate infrastructure, lack of affordable housing, existing environmental hazards, and the list could go on. Moving forward, we understand that we not only need to protect New York City from extreme events, but also the chronic impacts of climate change. We have the luxury and the privilege in New York City to have our resilience policy informed by regional climate projections that are developed by the New York City Panel on Climate Change, or the NPCC, which is an independent panel of leading scientists. The NPCC projects that by 2050, we will see a 4.1 to 5.7 degree Fahrenheit increase in average temperatures, 4 to 11% increase in annual precipitation, and 1 to 2 feet of sea level rise. By 2100, the high-end projections of sea level rise are up to 6 feet. So in 2015, the de Blasio administration put out the One NYC plan, which builds off of previous plans and puts forth an inclusive climate action agenda. The plan includes 4 core visions: economic growth, equity, sustainability, and resiliency. And the resiliency vision is comprised of 4 key goals: strengthening coastal defenses, protecting critical services and infrastructure, upgrading buildings, and ensuring that our neighborhoods are safer and more resilient. The One NYC plan outlines a $20 billion portfolio of projects, and I've included a map up here. We were told to keep our slides as slim as possible, that reach across all 5 boroughs. And of course, science is an important underpinning of this entire portfolio. But I actually didn't want to talk about the projects that we're implementing and delivering right now. I wanted to also talk about how we're thinking about resiliency beyond this post-Sandy portfolio. And one example of how we're thinking about embedding resiliency considerations across all city actions and investments is our recently released preliminary climate resiliency design guidelines, which for the first time establishes comprehensive, multi-hazard citywide guidance on how to incorporate projected anticipated impacts of climate change into the design of city facilities. The goals here are to institutionalize the work of resiliency into the ways we design and build our infrastructure, and to leverage our existing spending to ensure that we're continuing to build a more resilient city. The guidelines provide forward-looking climate data for sea level rise, storm surge, heat waves, extreme hot days, and precipitation, and identify how to use that data in light of existing building codes and standards. The guidelines apply to all new city capital projects and substantial improvements, which can include facilities as diverse as libraries, schools, drainage, sewers, bridges, data centers, public housing, or administration buildings. The other thing I wanted to mention is that our resilience strategy is not only focused on buildings and infrastructure, but also safe and livable neighborhoods. One example of this approach is the recently released Resilient Edgemere Community Plan. Edgemere is a majority-minority community with African-American residents comprising 62% of the population. Only 16% of the community has completed college, and the community's unemployment rate is 13%, or double the unemployment rate of New York City overall. The Resilient Edgemere planning process allowed the community to identify the many problems experienced in daily life in Edgemere. A primary concern is that the neighborhood's geography and topography contribute to regular flooding and ponding, but other major concerns include lack of access to the beach in Jamaica Bay, the blight of vacant land, attached housing that is difficult to elevate, slow and unreliable transit service, and little commercial activity. So the strategies and projects that emerge paired recovery and resiliency investments with a new comprehensive long-term community vision that includes new infrastructure and amenities, mixed-use housing, and flood protection. The Resilient Edgemere Community Plan also acknowledges that there are homeowners in the most vulnerable portions of the Bayfront that are particularly vulnerable to wave action from coastal storms. And the plan establishes a hazard mitigation zone in the most vulnerable areas where the only recovery strategy available is buyouts. So eligible residents are then offered assistance to relocate further inland, and the city can use the land to develop further coastal protection measures or improve waterfront access. So the Edgemere example underscores the need for social science and related data in addition to physical science, as well as robust community engagement. My last point is around how we measure this work. So the city depends on science and data to deliver its infrastructure projects, institutionalize resilience, and build livable communities, but we also need science and data to measure the impact of our efforts and capture the multiple benefits of our work. With our current portfolio of projects, how we measure the benefits and costs of our work is often dictated by the federal funding that is supporting our work. Moving forward, we need to measure our efforts in a way that captures not only how we are making New York more resilient, but also more equitable. And finally, metrics that capture the benefit of these project to private stakeholders will be critical to making the case for private finance moving forward. I want to now introduce my colleague Katie Orff, who is testing these ideas on the ground through design. I just called you Katie, I'm sorry. Katie, okay.
Hello. And next slide, please. So my name is Kate Orff, and I'm a designer, and very excited to address this group. Basically, in an ideal scenario, oops, if you can back up one, my sort of expertise is this concept of designing for uncertainty, relative to these localized, temporary, nonlinear impacts. How do these manifest spatially in our homes, our communities, and our neighborhoods? This is a challenge of design, and this is my key point today. In an ideal scenario, you have a scientific, highly informed and highly detailed context, which then informs policy and financial instruments that then gets solidified in terms of planning and zoning and legal codes, which then a designer like myself interprets into a physical environment. But nevertheless, this kind of chain of operations is never perfect. And what I try to do in our work is to feed back on that change, to use design as a test and then re-inform up the food chain, if you will, back into planning and policy contexts. Here's an example. This is not a SCAPE project, but this is an example for how policy manifests on the ground and can take unintended consequences, right? This is on a walk the other day along the Gowanus Canal in Brooklyn, right? So this developer here is doing, quote unquote, the right thing, raising ABFE, advisory base flood elevation of his or her structure. But this is just one tiny example, and there will be multiple examples in the future of how these policy changes manifest in your immediate environs. So this is a parcel at the historic datum of New York, probably around 6 or 7, and here we're up at 14. But even just your kind of quick snapshot of this one moment in the city reveals access challenges, for example, physical mobility access, reveals equity challenges in the sense of this may be good for sea level rise, but it creates unintended stormwater impacts and puts everybody else on the sort of lower plane and pushes the stormwater a different way. It has ecological impacts. You can see just a vertical bulkhead wall with no maritime edge ecology. And it has social life impacts, right? It's walling off and it's creating a non-contiguous network. So that's just one project, but I guess what I wanted to communicate is that even if we get all the policy right and all the science right, that needs to then manifest in a physical urban landscape that is adaptive to sea level rise. So what I wanted to show today, and this is an example of sea level rise. There, someone mentioned Breezy Point earlier. Breezy Point, I took my students out to see a 14-foot high dune that was adjacent to a flat sandy area because the policy of the National Park Service is different than the policy of the adjacent property. That's city policy. So all of these things need to be coordinated, not only between policy and design, but also between federal, state, and local actors. So what I wanted to show in my 3 minutes is one project on the boards at SCAPE that is aiming to go beyond, here you can see the multiple, over 500 miles of New York City that aims to go beyond this scenario, which is the wall, right? This is the default scenario where we build walls, we fortify bulkheads, and this sheet pile bulkhead is essentially the default scenario of how we are dealing with lifting our flood elevation and dealing with our waterfronts. because I would say this current waterfront zoning needs to be designed better, right? It is boxing in. So this project that we are working on in Red Hook tries to challenge these existing planning scenarios. This is Red Hook, Brooklyn, and then the project I'm going to show you is roughly here. This is how Sandy was affected, and this is the sort of zoning, waterfront zoning context for this project. So this is how policy manifests on the ground, the existing current level of the street, and this is where the future building needs to be in terms of its base flood elevation, right? So that is a wall. That is a wall on the street. That is a wall that has multiple challenges for social life, for accessibility, etc. At the same time, so that is the urban side of the vertical bulkhead wall, which has no ecological value. So in this project that I'm going to show, I mean, we are really trying to challenge that, and we would sort of say that policy tends to overvalue dry land over wet. It overvalues and incentivizes passive recreation and distance from the water over water engagement and access, which leads to monotonous and reductive experiences in cities. We have to watch this with every kind of adaptive measure. And 3, it generates ecologically sterile environments rather than functional maritime and aquatic habitats. Where is all of this marshlands going to migrate to if we design our future cities with these vertical walls and barriers? So here's just an example. It's maybe hard to see, but how we began in this project to step down and create a ramp towards that streetscape that you just saw. Our goal is to create a gradient and creatively to interpret these regulations. In this case, for example, we have designed a bulkhead wall with low pH marine concrete to generate biological life and for shellfish and to create fish habitat. We have created an interesting experience that brings people down to the water. Basically begun to carve away that bulkhead, to step it down, to create zones of intertidal habitat and also zones of waterfront access. So of course, if you don't design, that's, first of all, this is what you get, and then the bulkhead wall. So we need to also train an entire generation of designers to be able to take all of this incredible information, policy context, and generate urban landscapes that are not only adaptive to sea level rise, but that are inspiring and beautiful. Thank you.
And our last panelist, Maria Schwartz, who is an atmospheric perils specialist and Assistant Vice President of Underwriting at Swiss Re. Thank you very much.
Thank you, Gavin, and thank you for having me. So as Gavin said, my name is Marla Schwartz, and I work at Swiss Re, which is a reinsurance company. So a lot of people hear of reinsurance or insurance, and it sounds boring. Insurance isn't sexy. You know, the commercials on TV are so bad. Insurance never seems to cover what you think it's going to cover. Your insurance agent is annoying to you. And so you might be wondering, you know, why is it that we care about sea level rise, and why am I here? And so if we could go to the next slide, or do I have a pointer? Oh. So what is reinsurance? How is it different from insurance? So reinsurance is insurance for insurance companies. And, okay. So in a traditional insurance community, you have various people that have risks. It could be their house, it could be their cars, and you collect premiums from a group of insured people. And the idea is that the losses from a few people in that community will be covered by the premiums that have been collected by everyone. And this works great. It allows you to take risks. It allows you to sink all of your assets into buying a home, or it allows you to practice medicine, or allows you to drive a car. But this system begins to break down when everyone in the community is affected at the same time. When there's a wildfire that burns down everyone's house, or when there's a flood that affects everyone in the community, or an earthquake or a hurricane. And so insurance companies, primary insurers, in an effort to try to mitigate their own risk, pass off some of their largest risks to reinsurance companies. And so, again, primary insurers are transferring their risks to reinsurers, and reinsurers, like Swiss Re, then pool all of these risks on gigantic scales. So we try to diversify our portfolio by insuring around the world, by insuring for many perils: hurricane, tornado, hail, earthquake, flood, cyber terrorism, drought, or pandemics, or life and health. And we insure across many lines of business, so property, casualty, life and health, et cetera. And the idea is that, in some years you might not have any earthquakes in California, so we can take premiums from people paying for California earthquake insurance and use that to pay for hurricane losses in Florida. And Swiss Re is one of the largest global reinsurers. And my role at Swiss Re is on the catastrophe and perils team. So we're part of the underwriting team, and we develop tools and technologies to help underwriters price insurance. And specifically, I'm focused on some of the wind-related perils, so hurricane, tornado, hail, and wildfire and winter storms. And there's separate earthquake teams and flood teams. And so when we had the call with Peter and he told us a bit about this panel, he kind of asked, how does sea level rise appear in your industry, or why is it something that's talked about? Sea level rise is always popping up when we start talking about hurricanes or flood losses. And flood losses are actually the most common and the most expensive natural disaster in the US each year. And unfortunately, the economic losses due to flood have been increasing since the last 50 years or so. And this is due to three main reasons. One, there's increasing property values. Homes are just becoming nicer, more expensive, and more costly to replace. The second is that there's a concentration of risks in highly exposed coastal areas. And you can see in these two images, the one on the left is showing what Ocean Drive in Florida looked like in 1926. There's nothing there. And then about 75 years later, you can see that it's filled with these high-end condos right next to the water. And then the third reason that the economic losses of flood is on the rise has to do with changing hazards. So that comes up both in climate change and affecting variability in the very tail of the risks, but that also pops up with sea level rise, because when we have hurricanes and there is storm surge, so the water of the storm that is pushed onshore by the winds, the storm surge losses are getting greater and greater. And we no longer need a major hurricane to have a major disaster. And so historically, private insurers or reinsurers didn't want to write flood risk. They thought it was just too risky, it was not profitable, we couldn't help people out. And so in 1968, Congress established the National Flood Insurance Program, which is now managed by FEMA, and the government really took on a lot of the public flood risk in the US. And this worked well for quite some time. It was designed to protect against moderate floods, but it was never intended to protect people and homeowners against extreme events. And unfortunately, starting in 2005, the NFIP really started running in the red. The losses from Katrina, Wilma, Rita, and then years later with Sandy and Ike really just put the NFIP under, and the premiums that were collected were no longer sufficient to cover the flood losses that were experienced by everyone. So in recent years, private insurers and reinsurers are now getting into flood insurance. We feel comfortable writing flood. We have better tools and technologies than we did 40 years ago to allow us to better understand flood risk. And this market is really growing. And as this market grows and as sea levels rise, you can imagine that we need to better understand how much sea level is rising, where, by when, and questions like that to be able to price insurance properly. And the key thing about pricing insurance properly is that it also allows people to have a much better view of their risk. So I think on the last panel, George said, flood insurance is not a guarantee, and some people misperceive it as a guarantee. It's definitely not a guarantee, but if you're paying the right amount for your insurance, you should have a better view of your risk. And with kind of taxpayer-backed, subsidized programs like the NFIP, some people might not have the most accurate view of their risk, but if it's priced properly, you should understand where you should and should not build your home. And so, again, how do we use information about sea level rise? Well, one thing that I do on a daily basis is modeling and assessing storm surge and coastal flood risk. And this is really a key part of insurance and reinsurance companies that are writing flood. And so we really do care a lot about how much are sea levels rising, what does it mean for storm surge, what will Hurricane Katrina look like with an additional 2 or 3 feet of sea level, and ultimately, how does that translate to large property losses, and how can we use information about that to encourage developers where or not to develop in the future. So I think I'll stop there, and I can take questions on the panel.
You must be a lot of fun at parties, eh? You must be a lot of fun at parties. Like 4 horsemen of the apocalypse every time you get a cocktail. It's great. Okay, so I've got a whole bunch of questions here that address varying parts of what you're doing. Both the design and the planning solutions that you presented were very localized, right? So they're benefiting very local places. But sea level rise is going to affect, the whole city and the whole coastline. How do you plan at that scale? How do you design at that scale?
Want to take that for the citywide? Sure. So I think, as Kate mentioned, New York City has 520 miles of coastline, but we also find that each neighborhood experiences a different risk profile. And so we have been designing a multi-layered strategy that includes solutions that we can implement now, midterm solutions and solutions that are more long-term. At the same time, we're taking each neighborhood's unique risk profile into consideration. So I mentioned Edgemere in my remarks. In the Rockaways experienced flooding from 3 directions during Sandy. There was the storm surge that came over the beach and crashed into the homes behind the beach. There was inundation that came through Jamaica Bay and then spread into the neighborhoods around the bay. And then the drainage infrastructure actually was not equipped to handle the volume of flooding that the Rockaways experienced, and so there was actually water coming from underneath. That's not the case in all neighborhoods. So we've been looking at both the whole as well as these unique risks that each neighborhood faces so that we can address those risks.
Yeah, and I would just add that I'm very interested in this question because I feel that in a lot of ways, what we're trying to do is at the granular level make these things possible. But the reality is, at a state level, there's so much that could be done, right? You had mentioned the buyouts on the state level, right? Of just buying out very low-lying areas, incentivizing a sort of a retreat. That is a scale that could be clearly a game changer relative to, not looking at the fine-grained intersection. I think the other aspect is at a federal level, just to throw out an example, is we have, I loved your example of Miami with the before and after 1930 and today. We have developed our barrier islands, for example. I mean, I feel like at a federal level, a very kind of clear concept would be how to proactively plan for reusing this ecological infrastructure that is the barrier island. If you look all up and down the New York Bight, that is our protective physical feature, and to be able to address that more holistically rather than on a parcel by parcel basis. Of course, much of the United States is set up to enforce private property, and but there are other tools in the game relative to financial instruments and that could help kind of address some broader scale changes, and we need to be doing that, I think.
Okay, thanks. This is one very specifically for Swiss Re. Have you got a map that shows where there are no large risks from flooding, fire, tornadoes, so that we can move them?
There probably is one. And it's interesting. We talk about this often, how there are places that might benefit, I hate to say this, from climate change. If you move to like Minnesota or Michigan, there's a lot of water. It has been very cold there in the past. If you move there now, it might be a little bit warmer. And so it's hard to say exactly where you could ever move if you would ever be protected from anything. I don't think so. But if you were to move anywhere, the Midwest is a pretty nice place.
Your mileage may vary. So this is also perhaps one for you. So you're a private company, right? You're not a governmental organization. And there are a lot of sovereign and sub-sovereign entities that are using catastrophe bonds to help transfer risk outside of the governmental pool. As these threats and risks continue to grow, are there more effective ways that the governments and the regions can engage the private sector? Is it only through catastrophe bonds and reinsurance? Or are there other things that we haven't mentioned already?
So catastrophe bonds and insurance-linked securities and then traditional insurance or reinsurance are probably the key components to really trying to manage your risk. That being said, there's always innovative solutions that are coming up that can help populations in specific areas with specific needs. And we often make the analogy that when people started driving, we always said, oh, there's going to be drivers that could just never be insured. No one ever wants to insure like a 16-year-old male driver who wants to just go really quickly. That's too much of a risk. But with improvements in seatbelts and improvements in safety testing and improvement in our ability to understand how, what is the risk of driving the car, we were able to insure 16-year-old male drivers. And it's the same thing, that there are some very, very high risks that it might not be appropriate to have cat bonds or to have traditional insurance, and there's always innovation to help with that.
Okay, thanks. So here's a more optimistic kind of question. If New York successfully became a leading city in sustainability and design with the problem of coastal sea level rise very much to the fore, do you think that impacts how climate change and resiliency are viewed in the interior, in places that don't share either New York's demographics or political views or attitudes to some of these questions?
I don't know the answer to that question, but I think we take our role as a leader in this field very seriously. We're involved with several networks of cities, both global and domestic, and are very open to sharing the lessons that we're learning, as well as learning from what other cities are doing. So we hope to keep that dialogue going for sure.
Oh, yeah. Is New York learning from its failures? I've got one question here, which is a tad aggressive, but they mentioned the Build It Back program, right? Has that been a success? Is it something that we can learn from how well or not that has worked out to tell people?
I don't work directly on the Build It Back program, but I can tell you that we are certainly taking stock of the lessons that we've learned from the Build It Back program so that we can apply them in any future disaster recovery.
Do you want to share some of those lessons?
Like I said, I don't work on the program, so I'd hesitate to go into them here.
No, okay. I don't want to push you too much. But I mean, do you think that your work here on the Guaymas Canal, and I mean, is your office based in New York?
Yes.
Yeah, and the Swiss Re office, is that here too? Yeah, I mean, so New York is a center for both these design and financial instruments. This does penetrate, right?
Yes, I think New York is a global city and is looked to for its response. And I mean, I think that I'm very also interested in looking at other ways in the past that civilizations have lived with water. Constantly, the Dutch are being held up as an example of this sort of techno-managerial, comprehensive approach. But I think, the Vietnam, the way that Bangkok, Thailand evolved to sort of live alongside water in a non-catastrophic way, there are probably multiple lessons from around the world that could be applied. But I do feel like eyes are on New York now because of the Sandy event. And I think that the city is responding in kind. And I would say that it is, I love being called a stakeholder because normally I'm the other side and people are like, no, I'm your stakeholder. But it's very, I think the challenge is that our entire implementation framework has been set up in an era of perceived certainty and in an era where things are siloed. So you have this group here, and you have this group here doing wastewater, and you have this here doing buildings, and this group is doing planning. But the reality is climate cuts across those things. So the onus becomes on us or others to be able to try to loop together all of these siloed groups. So I feel like New York has a lot of more work to go in that regard, as much as progress has been made.
Okay. These are these are questions perhaps mainly for Bavishi, but Jainey. So I mean, could we mandate just no more building in floodplains? I mean, could we just say you can't build there, as opposed to allowing the insurance market to tell you, or the banks with not giving you a mortgage or giving you a mortgage in order to be able to build there? Can we control it at that level? And is that a sensible thing to be doing?
So our city planning department actually has explored and pursued the designation of special coastal districts in a couple of particularly vulnerable areas of the city. And the strategy that essentially these special coastal districts allow us to pursue is dedensification in the area. So we'll be limiting development in these areas that are particularly at risk. So that's as far as the conversation has gone so far. I think that it's an important tool that we now have, this kind of downzoning. But even that came with very intense and robust community engagement. And I would just say that's a really critical part of this kind of policy development.
Right. I mean, that comes up in a number of other questions. Like, there are things that we can do that are design-wise, that are mandated, but this is all part of a bigger conversation. It's all part of a bigger conversation about improving access, reducing inequality, improving access for all the people in the city. How do we keep all of that joined up? Like, how do we keep that at the forefront of all the decisions that are being made, while at the same time still having to deal with the fact that it's not everybody that's building a building on the Gowanus Canal, and it's not everybody that's going to benefit from those buildings?
I think it's it's to recognize that building resilience is a very interdisciplinary effort, and to break down silos, as Kate mentioned earlier, where in the Edgemere example, for example, as an example, we took a really holistic approach to looking at not just the climate risks that the community faced, but also the other challenges that the community faced, and brought the right agencies and decision makers to the table in order to have those conversations and really drive towards effective solutions. I think that's a good model, and we need to be thinking about how we can apply that elsewhere.
In the case of, I would just say, Norfolk, Virginia, or Miami, Florida, the idea of just saying you can't build in the floodplain is completely, like, the entire city is somehow impacted. So I also feel like what is so challenging, and again, this is the sort of legacy of the modern city, is we have evolved, and our cities have evolved because, for economic reasons, for other social reasons, against and with our water bodies. And so the idea of just simply some moment of saying, like, we're not going to do that anymore. The fact is that we have tremendous built fabric in these areas, and so to just, I feel like that's deeply unhelpful as a sort of starting point. What I would, advocate for is, more progressive kinds of ways of not just saying you can't do this, but it would be like, here's what you can do. Here's an incentivization to densify in a higher area. Here's incentivization through buyout. Here's incentivization to kind of, here's a densified zone on higher ground that would, help jumpstart and choreograph some of these processes.
And can I add one thing to that? There are some communities in which we are exploring how the community can live with water in a different way than it has in the past. And so, I just to build on what Kate was saying, there's sort of a spectrum of strategies that are available to us, and many of these are evolving, and I think we're looking at flexible pathways to come up with innovative solutions.
Okay, so I mean, you mentioned a couple of things like the economics, and you mentioned the importance of the pricing insurance correctly, but most people are dealing with banks and getting mortgages, and companies and developers are getting bond rating for what they're trying to do. Do you get a sense that those industries, those financial instruments, are also taking into account all of these issues on sea level, or are they a little bit behind what the science and the sensible planning would be?
I think they're definitely on board, and they have an accurate sense of what's going on. And those decisions, are told to you by the bank when you go to try to get your mortgage, and those decisions are coming to us from primary insurers, and we're also feeding them back to our primary insurers. We just had a client who's building a skyscraper in Lower Manhattan, and they were looking to get insurance for their building, and we kind of said, we cannot insure any of the contents of this building on the first 3 floors. You can build the building, but we can insure the contents above the 4th floor and up, but don't put anything down there, it can't be insured. And people, they say, yes, we'll build the building, but there are these stipulations that are becoming more and more obvious and more important. It's amazing.
Okay. That's good. So this is a more general one, and this is kind of where we'll leave it. Where's the center for putting all of this together? How can people, individuals, get involved in both, their own community or in helping other communities that perhaps are less advantaged? Where is that happening?
Colombia? No.
you don't have to say that.
No, I'm just kidding. No, I think that it's a challenge, and I think the point that you brought up earlier is that climate adaptation is a layer on top of so many other challenges that we face as a society, whether it's education or equity, and so I think that's the core challenge, is that climate change is baked in. We need to make modifications of how we work, but then there's we have to kind of move that into this broader problem-solving perspective that is really looking more holistically at some of these issues than we have done in the past. So I don't know if there is a center, but I would say that institutions like Columbia have key roles to play in synthesizing the research, in projecting and providing base knowledge that can help governments provide baselines and create standards for action, and we can also provide a sort of a window into these solutions that have multi-scalar impacts.
I would say that it's probably unhelpful for there to be a center, because we actually need everyone to do their part. We need government to be thinking about incentivizing through policy. We need the private sector to be partnering in the work, thinking about creative ways to finance the work, and advancing market-based solutions. We need our partners in academia to be helping us build knowledge and ensure that we're advancing the science and basing decisions on that critical scientific underpinning. We need schools to be helping ensure that the next generation of leaders are aware of these challenges. So I think that there are many centers, and that's the beauty of it, right? And we need it to we need the work to continue to evolve in that way, where we're seeing hubs and spokes kind of come together.
Right. One of the interesting things that came up in the conference earlier today was this notion of co-production of information. Sometimes people talk about academia and sciences coming up with problems and then telling people what to do, and then other people implement them as if it was like this one-way pipeline for information to go from theoretical to practical. But the fact of the matter is, what we decide to work on should be informed by the questions that the policymakers and the stakeholders and the financial analysts have, and then we need to work on what is tractable to do, because there's lots of things that people want that don't actually exist and that science cannot provide, right? Like certainty on 30-day weather forecast is not possible, regardless of how useful it might be. And so that notion that the academic community, the scientific community, has to be working in a collaborative conversation with all of you and the other people that we were talking to earlier today is really critical. I mean, there isn't a center because there's always this back and forth, and I think that's like that hub and spoke. As long as we've got two-way communication along with those hubs and spokes, along the spokes in the hubs, that's really the key. That's really the key thing. Did you want to? Mara?
No, I was just going to say that I'm not sure if there is a center, but if you're trying to find a center or centers, I think it's really going to rely on this communication pipeline, a strong communication pipeline between academia and the researchers and the stakeholders and government and private industry also. And without communication with all of those people, it's almost like the science is falling on deaf ears.
Are any of you involved in the National Climate Assessment as stakeholders?
My office is.
Your office is, yeah. So that's one forum where this is happening, hopefully. Okay, well, we have to kind of wrap it up. I'm going to thank the panelists very much for their fascinating talks and their interaction with the questions that we've had, and thank you very much to the audience for giving those questions. So let me. I've been given the chance to come up with a few final thoughts. This is a tough problem. There are complexities at every level. Complexities in the science, complexities in the dynamics of ice sheets, in how sea level gets transmitted, and there are far, far more complexities in our human societal response to both what we're doing to change the climate, but also in how we adapt to the changes that are already underway and that are still to come. But I think it's very important that we don't get caught up in the complexity, because that can be a rabbit hole, and you can just kind of get deeper and deeper in, and then you never come out to see the bigger picture where you actually have to make decisions. But I think what we've seen today, both from the science and from the stakeholders and the financial industry, is that people are making better decisions. And our challenge with climate change and our wider societal challenges is that this is a long-term and chronic problem. It's not an acute problem. We haven't broken our arm and we're rushing to the hospital to get it fixed, and that's the only thing that matters. Climate change is one of those things that is going to be impacting us for this year and next year and the next decade and the next 30 years and the next 40 years. And the solutions that we come up to and the strategies that we employ to deal with that have to also be sustainable over that long term. And so we have to be pushing for people at all the different levels to be making better decisions and more informed decisions and more joined up decisions. You said very, very sensibly, you have to be holistic decisions. You have to be thinking about more than just one thing. And we are doing that. We are slowly but surely making better decisions. And I think New York City actually is a bit of a beacon in terms of the plans that it had, both in the previous city administration, the Plan NYC in the Bloomberg administration, and the One NYC plan that's really the follow-on. We are making better decisions, and we do have choices, right? The future is not set. There is a future in which the world in 2100 is a totally different planet from the one that we're living on right now, where we burn all the fossil fuels that we can find. There's a different future, one in which we reduce the amount of carbon emissions, one in which climate change is not stopped, but it is slowed, and where we make adaptation decisions that are more joined up and holistic. And it's still up to us to decide which direction to go in. We're in a choose your own adventure book, and we've only just started. And those chapters that are really going to determine whether my child or Stott Stringer's children or your children or the next generations suffer or adapt and thrive, those decisions have yet to be taken. And they're decisions that are being made every day at the individual level, at the community level, at the city level, state level, and at some point soon, I hope, again at the federal level. Until then, we can continue to make better decisions for ourselves. And I think that despite the complexities, we do know more about the world and our society than we sometimes let on. And we do have the capacity to be making better decisions for the future. And I hope that everybody here and everybody who's watching online can participate in making those decisions, better decisions and more sustainable for not just now, but for the next many decades. Thank you very much for turning up. Thank you very much for participating and being engaged in this issue. And thank you very much to Columbia University for hosting us. Thank you and good night.